Suppose that if we have 10 propositions, if we have 10 propositions and you have been asked to make a truth table, make a truth table for these propositions, and you know that the proposition is that statement which is either true or false, but it cannot be both. To make a truth table for that, you need 2 raised to power 10 rows, and that is approximately, that is exactly maybe 10 24. So it is not convenient to make a truth table with such number of rows. So it means truth table cannot cover all the propositions to make a judgment, to make a judgment on truth or true or false statement. So here comes the rules of inference. So then we have a rules of inference. Rules of inference is that you start with some assumptions or postulates and you continue from one statement to another, then so on, and reach at the conclusion. So you start with one postulate and continue with the conclusion. That is called rules of inference. In rules of inference, there are different subcategories or classes or names in the rules of inference. One is Modus Ponens. And there are other statements as well that we will talk about in the next video. Let me just start with some example. Suppose we have a premise 1. Premise 1 is if the code compiles without errors, then the program will run. This is premise 1. And if the premise 2 is, suppose we say that the code compiles without error, then what conclusion can we draw from here? If the code compiles without error, it means the program will run. So if someone claims that with the premise that the code compiles without error, it means that the code will run. The conclusion is, therefore, the conclusion is, therefore, the program will run. Software program that we are talking about will run. So this is example 1 about the modus ponens. I will talk about the symbolic way how to write the modus ponens, and then we also talk about tautology, how to write the correct statement. Okay. So the next example is another example. We have example. Suppose we have premise 1. If a patient if a patient has a fever, above 103 degrees Fahrenheit, then they need immediate medical attention. This is premise one. And suppose that premise two. Premise two is, we say that this patient has a fever of 104 degree Fahrenheit. So what conclusion we can draw out of that? We can say that if the patient has one temperature above 104 degree, then the premise one says that they need immediate medical attention. So the conclusion is, therefore this patient needs immediate medical attention. Okay. So these are the two examples of modus ponens. Usually you cannot explain modus ponens by examples. You have to write the symbolic way or mathematical way to write the modus ponens. So we see that this modus ponens starts with if P then Q, then we can write. Now I am writing it symbolic way. Symbolic representation. So we say that if P then Q, it can be written as P and Q. If one of these statement is true, if for example P is true, then we conclude that therefore Q is true. That's how you explain modus ponens. Okay. Now the question is, how can we write the tautology for that? Let me just write a tautology for that. So I repeat, the general way is, you can even write, I have written P implies Q, and if P is true, then the conclusion is true. But you can also write modus ponens as P implies Q, and then you write horizontal line, and then you conclude that therefore Q is also true. And what is tautology? Tautology is a symbolic way to write the correct statement. Tautology for that. What will be the tautology? So tautology can be written as P if P is true and P implies Q is also true, then we can conclude that Q is true. If this statement is true, if this is true and P is true, then finally Q will be true. Okay. So we are talking about P is true and it follows that as well. Then the second statement is true. That's how you write the tautology. So if you are asked to write the tautology for modus ponens, then you have to write this statement. The conclusion is true. Okay. Thank you for watching.